Pessoal, boa tarde a todos. Já são 2h05. Vamos dar seguimento, então, à nossa conferência extraordinária do ciclo de conferências do professor Marcelo André Barcinski. Hoje a gente tem a honra de receber um palestrante internacional, muito renomado. Vou fazer uma breve introdução dele aqui. E vou falar inglês, obviamente, porque ele não fala português. So, thank you very much, Dr. Gan Zhang. I'm sorry for mispronouncing your name. But Dr. Zhang earned his PhD in organic geochemistry and is a research professor in organic geochemistry at the Gan Zhang Institute of Geochemistry. Since 2016, he has served as the head of the State Key Laboratory of Organic Geochemistry and leads a facility for radiocarbon dating using accelerator mass spectrometry for environmental studies. His research focuses on persistent organic pollutants, compound-specific radiocarbon analysis, and extraterrestrial organic matter. Dr. Zhang has published over 550 research articles in peer-reviewed journals, receiving more than 26,000 citations with an H index of 83. So thank you very much, Dr. Zhang.
Okay. Thank you for the introduction. Hello, everybody. Good afternoon. Should I? Okay. Yeah, we've been very excited to be in Rio, a beautiful city. And in the last 2 days, we visited several places of the city. It's a really nice and memorable experience of for all of us. And I would like also to thank Iago and Professor Torres for inviting us to come to this very great place. And finally we have the opportunity to visit different places of Brazil to experience your very interesting culture and beautiful sceneries. Today, I'm going to talk about the atmospheric monitoring of emerging contaminants. I think I just had several chats with our colleagues in this group, and I found that many of you are quite familiar with this topic. So I would more focus on an introduction of Chinese Academy of Sciences and our institute. Yeah, this is a screenshot that in February 28th we had a Zoom meeting with Dr. Jager and Dr. Roland Weber in Germany. Then we discussed how we can probably do some collaboration with each other, and in particular, Roland Weber came to know that my group is going to do some analysis monitoring of HCBD, hexachlorobutadiene dienes. And he also knows that we have a ANSO program aiming at monitoring of emerging contaminants in global southern countries. And then Roland suggests that we should get contact with Iago and colleagues in this university. Maybe we can develop some kind of collaboration together. And I start with the introduction of Chinese Academy of Sciences. This Chinese Academy of Sciences is actually, it has been the cradle of science in China. Even the Natural Scientific Foundation of China, we call it NSFC, was rooted from Chinese Academy of Sciences. And even the Ministry of Earthquake is developed by the Chinese Academy of Sciences. And so as we have across the country, we have over 100 institutes, CAS institute across China, and something like 60,000 staff and 8,000 research students. Most of them are PhD students. And we have 3 universities. One is the University of Science and Technology, which is the top one in China, and the University of Chinese Academy of Sciences. So all our PhD students are registered in UCAS, and then but they do the work in different institutes. And then another one is Shanghai University of Science and Technology. So in the country, actually, the CAS has nearly 90 state key laboratories, which these state key laboratories are the backbones of Chinese basic research. And we have 47 national engineering centers. And also the annual budget is about 120 billion yuan. I think the yuan is almost similar to the Brazilian money. So it's something like 100 billion Brazilian money for the annual running of Chinese Academy of Sciences. And the CAS serves the country for basic research and the country needs, even including military and also people's well-being, like our people working on environmental protection. And also CAS host over 85% of China's big science facility, like these huge telescopes, lots of such things, a huge one facility. They are operated by CAS on behalf of the country. Yeah, there's something wrong? Yes. Okay. I don't know why this picture. Oops. Sorry. Anyway, forget it. I draw a map. Just want to show the places of Rio and the places of the location of Guangzhou, the city I come from. Actually, we are just both close to the tropical. And Guangzhou is located on the Tropic of Cancer, the north side, and the Rio is the south side. We're something like symmetry cities. And our institute is called Guangzhou Institute of Geochemistry. We have around 300 staffs and over 600 research students. And we have 2 key laboratories, which are very important. One was isotope geochemistry, and then another one is, which I have been ahead, is organic geochemistry. And there's something wrong with my slides. Okay. But actually, we're now changing because the country, they want us to do something more clearly. They don't understand isotope geochemistry, the government. They don't understand the organic geochemistry. So now we change it to, the first one is something like solid earth sciences and mineral energy resources. So we're working on composition and structure of deep earth, geodynamics and the lithospheric evolution of the earth, and also mineral ore deposits and oil and gas geochemistry. So we can call this a solid earth science department of our institute. And I'm from the environmental science and technology department. So we do advanced mass spectrometer technology to make machines. And the second one, we work on environmental geochemistry and the ecotoxicology of different kind of pollutants and the carbon. And also the solid technology for pollution control and engineering. Yeah, it works. So it's like in our institute, we have 300 research staffs. We recruit each year around 80 PhD students. So we have 5 PhD programs. But the newest one is planetary sciences. Even I myself and Dr. Zhang here, we're working on something like the organic in the lunar or in Mars, on Mars or something like that. And we have 9 master degree programs. So we have each year we have a quota of 80 MSc studentship, 80 PhD studentships. The institute is quite well equipped. I think it's the best in the world. So the total investment on instrument up to last year is something like $100 million US. So we have all sorts of different kind of machines, instruments for organic analysis and characterization, inorganic and isotope analysis, mineral structure, morphological, high temperature, high pressure simulation facilities for deep earth research, and also biotechnology labs, all sorts of things. And in my group, we have something like 12. We have 12 staffs, including 2 research professors, Dr. Jun and me, and 2 associate research professors, these 2. And we have 2 senior technicians. And in our group, we have something just set up for private use. We can say private use. It's not open because we have a lot of public instruments, but this is just attached to our group, like GC, MS, LC, MS, preparation, high pressure liquid chromatography, and this is preparative gas chromatography, and we have a dedicated radiocarbon measurement machine, which is called accelerated mass spectrometer, and this has been the biggest one in South China. And we're leading the technology in environmental radiocarbon analysis in China. So we currently the research topics in my group, including persistent organic pollutants, you know quite well, microplastics, Shizhen is working on that, and tie-wear particles. And recently we think tie-wear particles are very important, because now there are more and more electronic vehicles in our city. More than 40 to 50% of new cars sold, they are electronic vehicles. And EVs, they are much heavier than normal gasoline cars. So they have a high tire wear during running on the road. And because China has been input a lot of resources in improving the air quality. And now the tire particles, according to our recent findings, is very important contributor to PM2.5 in our city, in many cities, in many Chinese cities. And also we do something very specific. It's called a compound-specific radiocarbon or carbon-14 analysis. So we're able to isolate one compound from any kind of environmental matrix, and then we measure the radiocarbon of this compound, and then we can tell you how old this carbon is, this compound, how old it is. This can be used to tracking the sources and the fate of carbon. So actually the carbon has been another major research field of our group. And then we work on black carbon. We work on the radiocarbon of carbon dioxide. Just want to know how much carbon dioxide is coming from fossil fuel combustion, which is the main target for carbon nutrition. And also, Gan Zhang and I also work on astro-organic geochemistry. We analyze potential organics in the lunar soil. We found something we're going to submit these days. And also we are planning for the Mars, because China is going to collect samples from the Mars in 2013. And just the day before yesterday, we called the Chang'e 6 mission completed. Just brought back the lunar soil from the other side of the moon the day before yesterday, and we are going to write a proposal. We ask for the samples. We look at the organics potentially in the lunar soil. We did find it in this side of the moon, in the near side of the moon, in the lunar soil, but we're going to look at the other side of the moon. And so professionally, I wanted to talk about the chemical pollutants, a global challenge, But I think all the colleagues actually know quite well about this, but I will try to deliver some of my source or my selection. And also I will talk about atmospheric monitoring and emerging contaminants. Yeah, it's a world of chemicals. Everybody knows. In 2 minutes, every 2 minutes, a new chemical will be introduced to the class or chemical abstract services. I skip this. So in my mind, most of the people, they will talk about the sources of chemicals, which is very important for control it. But if we think about the origins, formations of chemical pollutants, that's quite interesting. So I put several items here. The first one is industrial chemicals, like pesticidal, persistent organic pollutants. We all know it quite well. The second one is unintentionally produced byproducts, which we don't want to use it, but we produce this as a byproducts during heating or during during the synthesis of other usable products. And the third origin may be the environmental transformations, like triclosan in our toothpaste. They may be changed to dioxin, very toxic in the environment. And the fourth one may be the nature toxic chemicals, those produced during biomass burning, and even some marine origin, some like marine biota, they can produce some kind of toxic chemicals. So these are the raw origins or the formation of chemical pollutants. And I like these slides I made several years ago, that in this tiny biota, in the very deep trench of Mariana, they found high concentrations of a kind of flame retardant chemicals in this. For me, this means that it's a new evidence that these toxic chemicals, they are everywhere in the deepest ocean, and also in the Arctic, in the Antarctic, and also in the Tibetan Plateau. And this one tells us more about the time scale of the negative effects of toxic chemicals like PCB, polychlorinated biphenyls. So it's this kind of modeling work because we found high concentration of PCBs within kilowave tissues. But they did the modeling, the people from the United Kingdom, they did the model, and they say this will precipitate key risks during the next 100 years, which means these PCBs, which they are forbidden from the early 1970s, but in the next 100 years, it still works. It still acts negatively to the whales. So 100 years at least, and this one is. So I like this one. It's a Canadian research. They have 2 pounds. They put this kind of EE2, which is as ECO and ECO estradiol, which is kind of contraceptives. They at a concentration of 5 to 6 nanogram per liter, which is very low. And in Guangzhou, in my city, the concentration in the river much higher than this one. So after this, they put these drugs in this in a pond for 7 years at such a low concentration. They found big problem that the collapse of the fish population, which means these toxic pollutants, they not only attack individuals, they also attack the full population. So there are these 2 books everybody knows, Silent Spring by Richard Carlson, and also A Stolen Future. This one is for DDT, and this one is for endocrine disruption chemicals, EDCS. But as a geochemist, I like this very much. They this idea of planetary boundaries supposed by the people from Stockholm University. of Sweden. So they figured out several planetary boundary. If any kind of planetary boundary is exited due to anthropogenic activity, and then there will be something wrong. And here they identify one is novel entities, which include new substances, in particular chemical pollutants, and also new life form. But in this kind of a version, they put chemical pollution directly, which means chemical pollution is regarded as one of the planetary boundaries. As we can see here, like some of them, like the nitrogen, already exited the boundary. But in analyzing all these 9 potential planetary boundaries, we can see here chemical pollution. The concentration of toxic substances, plastics, endocrine disruptors, heavy metals, and the radioactive contamination into the environment, it is still not quantified. So we need to know where the boundary is. And I like this one, and I think Yago knows Ian Cousins. Ian Cousins, he found one boundary. He said that the outside of the safe operating space of a new planetary boundary for per and polyfluoroalkyl substances, or PFAS. They found high concentration of PFAS in rainwater. However, this concentration already passed the US EPA lifetime drinking water health advisory level, past a Danish drinking water limit. So we can't just to drink rainwater because it's already high enough to impose negative negative effect to our health. So this is a very good example. Just one use PFOS, using PFAS, one group of chemicals to define or to indicate there's something wrong with chemical pollutants. And when we are trying to get money from different funding organizations, like in China, if we want to do something related to international collaboration, in most of the funding calls, they ask us which the global sustainable goals you are focused on, and or SDGs. So I identified 11 out of the 70 SDG goals. They are all related to chemical pollution. So we will not lose our job because all the funding agencies, they want us to focus on that. And, okay, I don't know. Okay. I will talk more about some of the chemicals. First one, how can there are 2 ways to characterize, categorizing chemicals. The first one is, as a geochemist, I will characterize the chemicals by geochemical behaviors. Some of them, they are very, we know the PBT, persistent bioaccumulative toxics, which is very dangerous to biota, and also the persistent organic pollutants. They are defined as the persistent toxic bioaccumulative, and also they are subjected to long-range transport, especially in the air or in They're not only toxic, but they are quite mobile, or very persistent, very mobile one. They are quite tightly related to groundwater of particular concern. This is a geochemical perspective of these toxic chemicals. And then we know which chemicals they like to stay in the air, which like to stay in soil, and which like to stay in water, etc. But there's another new one. Now people care more about the adverse outcome. Like, so we can categorizing, oh, it's difficult for me to pronounce, a chemical based on negative effects like carcinogenics, like PAH, asbestos, or like the endocrine disruptors, which would impose very negative effects on our endocrine systems. So to do this, now many people, they start doing effect-directed analysis, combine chemical analysis with bioanalytical tools together to find which is the culprit of any kind of negative effect to the biota. I like this this paper published in Science that they use this effect-directed analysis. Finally, they found something from the tire particles, which is called 6-ppdq. It's very very toxic to the salmons in San Francisco Bay, and they found a very specific compound using this effect-directed analysis. So why we need to cope this problem with international collaboration? I think there are four potentially reasons. The factors, processes leading to the global chemical problem. First one is natural transmission via atmosphere, water, and biota. Everybody knows. And the second one is global redistribution of the industries. We have very strong feeling about this in China. And the third one is global transfer of solid waste. We also have very strong feeling of this in China. And the global trade of commodities and food, in particular food. We have some kind of a study concerning this. And this one, I saw it on a wall somewhere. It's the global distillation model that these pops can evaporate from places like Rio and then drop down in the Arctic to Canada. And yeah, we are very happy because we're a southern country, we're living around the tropic. We're just gone, going to Canada. We're very happy, but what we found is not, because it's quite classic, so-called conceptual models. Actually, what we have done in China, we found it's not in many scenarios. Temperature is not the dominant factor. The dominant factor is the wind speed. Everybody knows if we stay downwind of the dumping side, something wrong. Even I'm hotter, but the things still come in. Okay. The second one is what we do have very strong feeling in China. It's global redistribution of chemical production capacity. I will give an example of PFOS and P4A. We can find it was produced by 3M company of Canada, America. The production capacity of 3M dropped down in the year of 2000 because people say it's a big court event in the United States. And after that, you can see they moved to China. You can see the production in China, and it increased sharply until now, even until 2012. It's just a kind of redistribution of PFOS production capacity from North America to China. And now China is the biggest producer of PFOS and P4A. But because of it has been just listed into the Stockholm Convention, now this production capacity has to be closed, and we have economic loss. But no problem. Okay, we do that. We're doing that quite well. And this one is global transfer of solid waste. If we look at these arrows, means the global transfer of solid waste, like plastic, rubbish. They are going like this way. They are all go in the southern country lines. And why these they are going? We call it the maritime Silk Road, Chinese saying, because the cost for transport by shipping is the cheapest. So all the rubbish, all the waste, they are transported around the global in Asia, in this such way, in particular electronic waste, and then make big environmental problems everywhere along these lines. China has been the biggest electronic waste, how do you say, the destination country. But China fully stopped it from the year of 2018. But this kind of business was stopped even I think it's 2010 or something like that. China already stopped it. But in 2018, China stopped the import of any kind of solid waste. And then the EU countries and the American, they protest. Why don't you accept my rubbish? And also, this is kind of a PCB transfer by the global fish trade. It's done by one of my good friends. They found actually in Africa, they don't have PCB in their basic environment. But the PCB concentration in the human breast milk in Africa, they're quite high. And then they tracked it. They found actually they are eating the fishes imported from Europe. Because Europe, in the environment, they have very high concentration of PCBs. And then it's kind of by food trade, there's a redistribution of toxic chemicals. Everybody knows Stockholm Convention on persistent organic pollutants. And China and Brazil, they are two countries, they signed this. Most of the country in the world, they signed this. And it's become a very big burden to China because China is a manufacturing country. And once you list one compound in the convention, and then China has to close this industry. And we are lag behind of the development of new chemicals, probably can be used to replace the very toxic chemicals. And then we lost a lot in economically. But this is China's standing that we do that, no problem. The dirty dozen, I skip this. And each year, when there's a new compounds listed in the Stockholm Convention, I modified my slides on May 2011, 2003, blah, blah. And these three are the newest ones because we can get research money while we are doing such things. And in China is becoming more and more serious about chemical pollution. And so we launched a new pollutants control action, officially, very high level by the central government from this year in May. That so we use a new pollutants in place of emerging contaminants because emerging contaminants means something that you don't really know whether it is toxic, whether we need to control it. But the new pollutants in Chinese sense means if we don't have a regulation to control one of the problematic chemicals, we call it new pollutants because there's new emission standards. So we need to develop new emission standards for some compounds never been forbidden, and then we put all these compounds into a new pollutants, which means pollutants without emission, something without regulations, something like that. So the government identified the key new pollutants addressed by this plan. First one is persistent organic pollutants. All persistent organic pollutants being listed in the Stockholm Convention list. And second one is the big group is endocrine disruptor chemicals. And the third one is antibiotics. So apart from this, the country will strengthen research on emerging pollutants like pharmaceuticals and personal care products, and also microplastics. We've done a lot in my group. And the country's philosophy can be summarized just into 6 Chinese characters, which means first we need to monitoring. do the monitoring, and then we do the assessment whether the situation is bad or good. And then based on the monitoring assessment, we do the prioritization, which compounds we need to ban, we need to forbidden, or we need to cut. And then after the prioritization, then for some of the compounds, you should forbidden from the use, make them disappear from the market. And for some of the compounds, you still need to do that, but we reduce the usage, reduce the amount to be used. And finally, there's a control technology, which means to control the emission. So in Chinese, we say it 测评筛净检控. Just these 6 characters, they summarize the key actions undertaken by the country. So I just, okay, the next, because the atmospheric monitoring of the emerging contaminants, I think most of you know quite well, so I give you some kind of a feeding. First of all, how to evaluate the effectiveness of the Stockholm Convention. We need something, of course, we need global or regional monitoring of the chemicals, top-down monitoring. And among all the environmental media, atmosphere, it's quite a good one. Imagine this is the area of Rio, the city. So we have 1 kilometer of atmosphere above us, and then we can have the air volume like this, very huge. But if we just pour 1 kilograms of toxic substances, which are volatile, we can finally get a concentration like 0.1 nanogram per cubic meter. And for this, we just collect 100 cubic meter of air samples. We can have 10 nanograms of the chemicals from this bottle. And then it's very easy for us to analyze it, to measure it using gas chromatography or liquid chromatography, which means this is very sensitive. So the air is a quite well-mixed media, and also the sampling is quite easier to be normalized. It's very sensitive to this kind of fresh pop use, and it's highly time-resolved data, up to hours. Of course, we can get some meaningful information from risk assessment, management, control effectiveness, and also the sources, seasonality, and the air transport. And we can publish paper using this. So these are the things, a high-volume sampler to collect gases and the particle phase chemical pollutants from the air. And I charted, and I know many of you had the experience to using these passive air samplers to collect pops from the air. And I'm just skip this. It's invented by Tom Hanna. And actually, a very early phase in 2004 and 2006, we did this kind of a snapshotting of pops in China, in Japan, in Korea, in South Korea. What we found in the year of 2004 with Tom Hanna, we found this high concentration of DDT concentrations in the southeast coast of China, similar. And in the year of 2006 also, we repeated, found similar things. So there must be something happening. Actually, we went to the site and we found it may be related to fishing ships, to these small fishing ships. Because during the fishing suspension time, the fishermen, they spray DDT containing anti-fouling paints to protect, to maintain the fishing ships. We found that, and we looked at the settlement in different, all the fishing harbors across the Chinese coastal line. We found very beautiful DDT chromatography traces there. And actually, in the year of 2009, just because of our work, the government has banned the illegal use of DDT in the anti-fouling paint of fishing ships. And also, this work was done by Shi Zhen, who is sitting Susan. We looked at the source apportionment of PCBs in Chinese cities. And many cities in Chinese, totally 28 big cities. And we also look at 13 types of emission sources. And we analyze 209 PCB, all the congeners of PCB using this high throughput analysis. And then we are able to do the source apportionment of PCBs. What we found is the unintentionally produced PCBs now dominate in the Chinese urban atmosphere. And most of them come from organic pigment industries and also thermal industries. But the e-waste, not email, sorry, the e-waste still contributes up to over 50% of the alkyl PCBs, not the other PCBs, just alkyl PCBs. This is another flavor of our work that we look at how this biomass burning can bake the soil and re-emit tops from the soil to the atmosphere. And we use passive sampler, we use molecular markers for biomass burning, and we do the source apportionment. What we found here is the biomass burning contributed to 9.3% of OCPs and PCBs in the atmosphere of these countries, Vietnam, Myanmar, Thailand, blah, blah. This we call it Indochina Peninsula countries. We also use this atmospheric monitoring to estimating the regional pop emissions quantitatively. This is done by combining air monitoring with reverse numeric modeling. Then we can know, like in our area, which is called the per data, how many tons of chemicals each year being emitted from this area. We found that the current emission of OCP, organochlorine pesticides, in the per data is 2.5 to 2.8 tons per year. It's far more less than the historic usage, less than 1 per mil, which means the control of DDT and HCH in our area has been very successful. Now it's only 0.1% compared to the historic emission. Yeah, we also use this to look at chlorinated paraffins in Japan, in South Korea, in China, and found you can see the bar in China. It's very, very high, almost you can't see it in Japan and South Korea, because most of this production capacity of chlorinated paraffin are concentrated in China. In China it's about 600,000 every year, but the other of the world, even United States, just 1,000. So it's not in the same magnitude where the industry is and where the pollution will be severe. This is early work done by Professor Li Jun. We're using the raising SIP path to look at these fluoroteramers alcohol, FTOH, across India, China, Japan, South Korea, etc. What we found here is in India, they have a very different pattern with the other countries. They have more these blue ones. And actually, one of my colleagues in Tibetan Plateau, they found similar signature, much more similar to the Indian ones. And then they made they know, oh, okay, it's come from India to Himalaya, not from China. Just some kind of stories, interesting stories. And what we really did for the countries that led by Shi Zhen, we look at in many Chinese cities, 18 cities, 28 sites, over 1,000 samples. We measured the air concentrations of different kinds of organic pollutants. And anyway, what we figured out is the most dangerous. We need to be highly focused. One is the organophosphorate flame retardants, or OPFRs. The second one is chlorinated paraffins. From the year of 2013 to 2018, this organophosphate, flame retardants, and chlorinated pesticide increased sharply, to increase by a degree of magnitude. I mean, so, but the short chain ones, they remain similar, but all the producers, they shift to the medium chain chlorinated paraffin, you can see here. And we give this information to the government. And also, if we do the risk assessment, we find this chlorinated paraffin, they are very dangerous. They are very dangerous, even compared to volatile organic compounds like like benzene here. This is chlorinated paraffins. And heavy metal in Chinese atmosphere is safe. So now these new pollutants or emerging contaminants, in particular chlorinated paraffins, in Chinese urban atmosphere should be paid highly attention to. If we look at this Chinese data, we can see pH is at nanogram per cubic meter level, concentration level. And this OPFR, short chain chlorinated paraffins, the medium chain chlorinated paraffins, they all reached similar concentration level as pH. So this is amazing for us, amazing finding. Oh, this is Tom Hanna, our friend. They use passive sampling to monitoring the so-called gaps, to monitoring air pollutants across globally. They did excellent work. Finally, okay. Give me 5 more minutes. I'm going to talk about the concerns of POPs along the maritime Silk Road. The maritime Silk Road, there's some phenomenon. First one is a shift of chemical production capacity I just introduced from developed countries to Asia or to the southern countries. In China, we call the east hyssop as west coast down, or the southern tilt of this chemical pollution problem. And also the shift of e-waste and other solid waste from developed countries to Asia, and the intensive application or exemption of pesticidal POPs in some of the tropical countries, and lacking of monitoring and risk assessment capacity. So I give this example in the year of 2018, I just said, China stopped all solid waste import. Before that, the plastic, they go to mainland China or go to Hong Kong. After 2018, right after this stop, you can see China and Hong Kong become very, very tiny here, from this big to this smaller. In the meantime, we can find in the media that 2018 there's something wrong in Thailand because China closed the door. And 2019, there's something in Malaysia then about solid waste. And 2020, something in Ghana. They need to handle this kind of solid waste. So all this is related to the Maritime Silk Road. So we had a research program called Southern Contaminants Program. And it starts from 2018. And we do environmental monitoring of chemicals in all these countries. Okay, it's Bangladesh. I skipped this. And then, but now we have a new program called the ANSO program, Morataksa. And it's supported by ANSO. ANSO is actually the Alliance of International Science Organization. It's managed by Chinese Academy of Sciences, but it's working on Belt Road initiatives for the promotion of shared development achievement and of the United Nations Sustainable Development Goals. So this monitoring and the risk assessment of toxic chemicals in the atmosphere, we picked out several countries that we can install active samplers because passive sampler is quite easier, but active sampler it's relatively difficult. So we picked out Islamabad of Pakistan, Paradani of Sri Lanka, Dhaka of Bangladesh, Malaya, Ghana, Kenya, etc. And also we have this ANSO training course, so they are open to different countries. The students may come to be trained. This is some sampling campaign. They are going on in different countries, almost 1 year already. And we have some brief results until now. We focus mostly on highly volatile persistent organic pollutant in the atmosphere. We looked at the HCH, HCBD, volatile methane, methyl silones, haloalkanes, a lot of things. And what we found is for everything, China is the highest. So we're very, very upset to find China in our city. We always have the highest concentration of the also. Final 1 minute. Yeah, this is HCBD. What Yago really interested. We can see the other countries have similar concentrations, but China is very much high. And we did analysis of the data. We found it's related to all sorts of industries because our city is close. The Periva Delta is the largest manufacturing base in the world, produce everything. So they are just from industry sources. But this, I stop here. Thank you for listening. And it's very tough for me to speak in this time, Chinese 3 o'clock, midnight. Okay, thank you for listening. Thank you very much.
Thank you very much, Dr. Zhang. Do you have any questions? So I have one question. I'm not from this field, but so you showed very worrying data on chemical pollution. And as a leading researcher on this field, I would like to know your opinion. What do you think about the goals and measures established by the United Nations to reduce pollution? Are we achieving any tangible, any real success, or are we just fighting a losing battle?
I'm standing here. Yes. I agree with all these international efforts. I think they are very important. If from the Chinese perspective, we have a say in China. You talk about it, I do that. This is the Chinese way of doing things. When people are talking about Stockholm Convention, we stop organochloride and pesticides. And when people are talking OPFR, maybe we stop next year. So China just do it. And because we know it's good for us, it's good for our people. This is Chinese thinking. And I have lots of examples like that. It's even for the green energy, you know that. European they are talking, American people they are talking, and then, okay, I do. We provide all sorts of solar cells. We produce everything, and now the EV cars occupied half of all the cars in our city, and it's increasing sharply. We just do it because we think it's good for us. It's good for the earth. Yeah, I think this Stockholm Convention is like for the PFAS. China has been the biggest producer of PFAS from the year of 2000. We earn a lot of money. We allow 3M to open a factory in some of our cities. And then when we decide to cut it, we are going to cut it. And also, they take it very serious, the government. So a lot of research funding for people such like me, we are able to do such to do things, trying to find a way to solve this problem. And so sometimes the Chinese government, including me, we think that if we take it very serious, we're going to solve it, no matter what kind of problem we face. Sorry.
Thank you, Dr. Gan, for the great talk. Complementing what you're talking about, we in Brazil, we have a short of few examples of the Stockholm Convention. So we have seen a decrease of endosulfan, so organic chlorine insecticide that we use in Brazil. So, but I guess the huge problem between China and Brazil that we have a little investment support to monitoring environment. So I guess we have still many fields to fulfill about the monitoring here in Brazil. My question is, how about the dumping sites in China? We have some problems here. Iago developed your PhD monitoring these dumping sites, chemical dumping sites. And here, really close to us, we have in Duque de Caxias City, it's close here, we call the Cidade dos Meninos, or city of the children's, or boys, anyway. So there we still have emissions, high emissions of DDT and linden, because after 50 years of the ban, all the emissions are close, all the productions or imports of this kind of pollutants. So my question is about China, how you deal with dumping sites. And another question is about the global change scenario or global warming. Do you think that heat waves or other types of extremely climate situations, how the role of this in the dynamic of distribution of pollutants in the atmosphere? So I don't know if you understand a little bit. Okay.
Dumpling side, it depends because we don't really have industrial dumpling sites, but mostly are municipal dumpling sites, and it has been a long time problem in our city, the third biggest city in China, and in any other big city in China, for the waste dumpling sites. Smells bad and also emits lots of pollution. But during the last around 10 years, I can say that now in our city, a city which has a population of 20 million, this big city, all the all the waste, they go to incinerators. So they are treated in 8 huge incinerators facilities in different places of the city. And from the last year, even the incineration company, they don't have waste to incinerate anymore because the capacity is too big. And then they from last year, they dig out the buried waste to burn, to make power, to make money. And I've been to all these it's state-owned companies, and they are very well built with a very high standard, and it's something like enjoyable if you're just wandering in the so-called factories, very very high tech. And this is the general way in China to solve this this dumping site problem, and in most of the city actually. I mean, bigger city. If it's a small city, it shouldn't be a problem. And for the sorry, for the climate change, if it is for POPs, I think a lot of people they really analyze. Think quite well about this problem, but in if we talk about pesticides, I think this is the real things that need to be highly concerned, because when there's a much warmer or high temperature climate, we need to use more pesticides, and for this more there will be more pests, and then we need to use more pesticide, and to just to make our food to be safe. So I think this pesticide problem may be, in the chemicals perspective, may be the most important thing related to climate change. This is my personal thinking. Okay. We call it food, climate, and pesticide nexus. They are tightening together.
Thank you for your excellent presentation. You have a talent to make complexity look quite simpler than it is, and this is very refreshing. I was very impressed by the size of the technological Disneyland that you described in China. Compared with the infrastructure we have here, it's really orders of magnitude less. And this is the result of the emergency of a multilateral world. You presented us with data of great areas of the globe that I never imagined in my lifetime that I would someday see this, because all my life this type of data were produced by North America or Europe, which don't give a damn about all these areas of the globe where you have made the measurement. So this is a practical example of how environmental health depends on a multilateral world with everybody involved and, if possible, coordinating and helping each other. In this sense, I have a practical question. We see from the media that China is being treated like a hound dog by the main forces in the West. And seeing all this technological park, my curiosity was, do all these equipments, are they manufactured locally, which means that if Elon Musk tomorrow wakes up in a bad mood and he says, I don't like China, so no more spare parts or whatever, would you be able to go on working even depending on his humor fluctuations?
All the days, most of our instrument is made by Europe or North Americans, because they are far more developed, well-developed than we do. And in the recent around 10 years, China started to make analytical instrument by ourselves, but they are not as good at as this Western one. We call it the Western one. So for top research institute, we are still using the instrument made by developed countries. But for the government use, like the air monitoring stations, we have all sorts of automatic monitoring machines. They must be made by China, and or maybe in collaboration with some of the foreign companies. after the problem between the United States and China, they do a lot of sanctions. They really they like sanctioning. Okay, so I'm not happy, and yeah. So actually, we're trying to make as more as instrument by ourselves, but at this moment, actually, we're still capable. We're able to buy instruments from the other country, and China has some kind of a philosophy that when you are you have investment in China, and then you can go avoid of. I mean, just like the famous analytical instrument company like Agilent, like Shimadzu in Japan, they actually opened a company in China. They have the factories in China. So it's Shimadzu, but made in China. Agilent, but made in China. They know that maybe there will be someday the United States say, oh, don't do business with China from tomorrow. No business with China. It's, and no, these days, actually, we have more and more Chinese companies. They're trying to figure out this problem. Even my laboratory, it was the state key laboratory of organic geochemistry, but now it's transforming. I'm the last king of the laboratory because there will be a brand new one. It's called Advanced Environmental Technology. And our first task, which will receive lots of money, is the development of advanced mass spectrometer technology, making instrument. This is will be our first task, maybe in half a year. Yeah, now it's in the process of a transition. We know that. And talking about the lunar, because we were excited because our I would call the Chang'e 6 just came back the day before yesterday from the other side of the moon. And actually, China was supposed to collaborate with European, but then we were kicked out. And then China said, okay, I do it by themselves in collaboration with Brazil. And then we're successful. We continuously, we make plan continuously. We will have samples from this side of the moon, the other side of the moon, Antarctica of the moon, from the Mars, all in our plan. But we do it without any kind of help from America, and with no collaboration with Europe because we have been kicked out. We never worry about that. And we have Chairman Mao, you must know. Chairman Mao said, sanction for 10 years. We got everything by ourselves. No worry.
Any more questions? Iago?
Thank you very much, Professor Zhang, for the incredible presentation. It was very nice. And I have one simple question regarding the production of PFAS and chlorinated paraffins. We saw that after the restriction of PFAS, some of the PFAS in the Stockholm Convention, China is planning to stop PFAS production. And actually, Brazil used to import PFOS-F from China to produce sulfuramide antbaits. And that import stopped 2 years ago. So 2022 was the last import that we have records from China. So I believe the production is already stopping. So the offer is decreasing. And I would like to know if there is any forcing measure regarding CPs, because after SCCPs entering the Stockholm Convention, there was also a shift from the production of SCCPs to MCCPs. And you show that the chlorinated paraffins are a health risk in China because of the massive production, right? And do you have any idea about the production of MCCPs? Is it likely to continue for several years, or you think after the leasing in the Stockholm Convention that will probably be in the next COP, China could stop chlorinated paraffins production at all?
This will be a big problem in China because MCCP production in China is still going on because it's still under inspection by Stockholm Convention. But I think China is preparing for stop this. But we don't have any kind of alternatives for MCCP. And why we observed so high concentration of SCCP in the atmosphere in various environmental media of China is because of a historic production, I think. Yeah. Yeah, now we have lots of several students working on chlorinated paraffins in China's environment. For my personal perspective, CPS may be the most dangerous thing China environment faces.
Any more questions? So congratulations on the presentation again, and we declare our conference closed. Thank you.